Class, welcome to our next video on section 4.1. This is technically called Polynomials, Multiplicity, and Writing Equations, but I want you to understand that this is really the same thing from last video with this new idea of multiplicity. So we're going to introduce that first and then get into some practice problems. Okay, this idea of multiplicity, what that means is that we have zeros or solutions or factors that occur more than once, okay? So for example, if I look at this equation right here, y equals x plus 4 times x plus 4 times x minus 2, x minus 2, x minus 2, like this is multiplicity. I know that because I have an x plus 4, that would lead to a 0 of negative 4, but it occurs how many times? Twice. So I say it has multiplicity of 2. Okay, now I can do the same thing with this x minus 2. This would lead to a 0 of positive 2, and it has multiplicity of 4, right? There's 4 of them. So what I want you to notice here is at these zeros, or at these x-intercepts, at negative 4, right here, this does something different than what our video did yesterday. Every time we had a 0 yesterday, it just kind of went through that x-intercept, and then it went through the next x-intercept, and so on and so on. So keep this in mind, that when we had this multiplicity of 2, it kind of just touched that and went back up. And then same thing, when we had this multiplicity of 4, it kind of just touched it and went back up. Alright, keep that in mind. Now let's examine this equation over here. I have an x minus 7, so that's a 7, or a 0 of 7, with multiplicity of 1. And then I have x plus 2, so a 0 of negative 2, but multiplicity of 3. So now when we take a look at these zeros, or these x-intercepts, well, 7 multiplicity of 1, well, this is what we did yesterday. And negative 2 multiplicity of 3, right here, it's kind of doing like this S-shape type thing, but it's still going through the graph, right? It's crossing. Okay, and that's the idea that I need you to kind of understand. Multiplicity of 2 and 4 kind of bounced off. Multiplicity of 1 and 3 through. So hopefully you're starting to already recognize what pattern we're going to be talking about. As we come down here to the bottom. Oh, sorry, let me fix this. Okay, what we are going to say is that if r, or the power, if r is a 0, if r is a 0 of even multiplicity, okay, so if my factor has even multiplicity, then what it does, it brushes the x-axis. Okay, it doesn't go through, it just kind of comes here and it touches it and goes right back up. So I might say the word bounce a little more than brushes. That's just what I'm used to. Okay, it bounces off the x-axis. Well, what happened when we had odd multiplicity? 1 and 3. It went right through. So what we're going to say is if r is a 0 of odd multiplicity, then it crosses the x-axis. Now we can get really specific here, and we can say that it's going to kind of act like when we have a multiplicity of 1, it acts kind of like a line. Like if I kind of just zoom in here, it looks like I'm just crossing like a normal line. Oh, you might not be able to see that, right? It just kind of goes right through it, almost like as if the slope were, or if this was linear, I should say. Now over here, when I look at this 0, it doesn't look linear, right? It looks more like an x cube graph, which should make sense because the multiplicity is 3. But for what I care about right now, I just want you to understand that if you have an even exponent on your factor, well, then it's going to bounce. If you have an odd factor, it's going to cross. All right? So let's jump into this. Let's see how this works. All right. It says to find the zeros, roots of the polynomial, and then graph it. So the first thing we have to do is we have to factor this. And you're going to get really good at factoring this chapter. I see that I can take out an x squared, so I'm going to do it. Okay, I have factored this. I know that if I want to get the zeros, what do? I basically set the left side or the function equal to 0 and then I solve. Let's think about this though. I already know, so let's actually write that, my bad. X squared, x minus 2. Okay, I know what my zeros are. I'm going to have a 0 at 2. And how many times is that occurring? It has multiplicity of 1. And then how about at this x squared? This x squared means I'm going to have a 0 at 0, but this one has a multiplicity of 2. Alright? And why do I care about that? Well, because I know now that at 2, I should cross, and at 0, I should bounce. Hopefully that makes sense. I can go ahead, I can plot those right now. There's 0, 1, 2. Okay, I now have my x-intercepts plotted. Y-intercept? Well, y-intercept should be nice and easy. This is standard form. There's no constant, so I'm going to have a y-intercept at 0, 0. The last thing we need to look at again is the end behavior. And again, hopefully you remember, the end behavior, we look at the first term, or the term with highest degree. So I'm looking right here. I see that the leading coefficient is a 1, and I see that my highest degree term is x cubed, so this should go down, up. And now I have to put it all together. I know that I have x-intercepts at 0, 0 and 0, or 2, 0, sorry. I have a y-intercept at 0, 0, and I know I have to go down to up. So something like this. Now the last thing we need to think about is the multiplicity, right? If I just kind of went through and through, this would end up going down. I have to remember that at 0, I have to bounce. So I have to go like this and go right back off of it. And then at some point, I have to come back up to hit my other x-intercept. And we are done with that sketch. Okay, let's try the next one. Alright, this one's a little tougher, but again, very, very doable. What's nice about this one is this is already in factored form. Okay, so it's going to be really easy to get the zeros. It does make it a little harder to get our degree, which is the first thing we're going to do. But again, hopefully you remember from the last video that really what you can do is you can kind of just count the x's. And the reason is because if I wanted to get this back into standard form, I'd have to distribute everything, right? So if I distributed x plus 2 to x plus 2 to x plus 2, when I multiplied that all out, I would end up getting an x cubed. When I do the same thing with x minus 3 squared, I'd get x squared. And then of course I already see x squared and x squared. So I have x squared times another x squared, so x to the 4th, times another x squared, which is x to the 6th, times another, or sorry, not another, but an x cubed, so 6, so we have 9 x's, or x to the 9th power, which means that this is 9th degree polynomial. So again, guys, the trick, if you are in factored form, you need to count the number of x's to get the degree. Now, the end behavior, we just said it's going to be x to the 9th. The last thing we have to think about here is, what is our leading coefficient? Well, my a value, or what's out front, just a 1. So I know what? It's positive, and it's odd, so this should go down to up. Alright? Now let's start to list the zeros. I'm going to start with the easy ones. X squared, remember that that's just going to lead to a 0 of 0. And because it's squared, it has multiplicity of 2. The next nice and easy one is this x minus 3. X minus 3 as a factor means I'm going to have a 0 of positive 3. And again, this has multiplicity of 2. And my last one over here, x plus 2, means I'm going to have a 0 at negative 2. and it is going to have a multiplicity of 3. Now notice I skipped one, right? I skipped this one right here, x squared plus 1. This one's tricky, and hopefully you guys are starting to be able to recognize this, but when I try to set this x squared plus 1 equal to 0, and I try to solve this, I end up getting what? I get the square root of a negative. This is not real, okay? We can't graph intercepts or zeros if they're not real, okay? So what I need you to understand is that from this x squared plus 1, we don't get any new zeros. We don't get any new x-intercepts, okay? All right, so I can start to graph this a little bit. I know it's going to have at 0 and at positive 3 and at negative 2. Okay, so I have my x-intercepts ready. The y-intercept, what you really have to do here for the y-intercept when you're in factored form is you're going to want to plug in 0. But again, make this easy on yourself. As soon as you plug in 0 here, 0 squared is 0, you know that 0 times absolutely anything is still going to be 0. Okay, so 0, 0. Last thing we have to do is graph the polynomial. So I'm going to put my arrows. I know it has to go down. I know it has to end up. And I know that at negative 2, it's supposed to go through, right? It's supposed to cross because that's odd. These should be bounces. So let's see if that works out. All right, so I'm going to go through, and then I'm going to bounce, and I'm going to bounce, and I'm good. Okay? For sketches, honestly, guys, like, I don't know how high this goes. I don't know how high this goes. So that's not what I'm looking for. I'm looking for the correct intercepts. I'm looking for the correct end behavior, and I'm looking for the correct action at the intercepts, right? So because negative 2 was supposed to cross, I need you to cross here. Because this was a bounce, I need you to bounce. Bounce, okay? All right. Okay, I'm going to skip number 4 for right now just because this is more like last video, and I want to show you how to write an equation when we have multiplicity, and I don't want to take forever like my last video. So let's skip this one for now, and let's move on to number 4. And we need to write an equation of a polynomial with degree 4. Zeros are negative 1, 2, and negative 2, but this negative 2 has a multiplicity of 2. Okay? So let's think about this. We know that our polynomial is going to be an equation, so y equals or f of x equals. And let's start thinking here. Polynomial of degree 4 means I'm going to have 4 sets of parentheses. Okay? If my zeros, or let's pick 1, 0 first to start. If my 0 is negative 1, remember that leads to a factor of x plus 1, right? Does that ring a bell? I hope so. If I have a 0 at positive 2, that leads me to a factor of x minus 2. And then this one over here, minus 2, or negative 2, sorry, that means I'm going to have x plus 2. And because it's multiplicity of 2, I need to have another one of those. Okay? Now, it also says that the leading coefficient is 2, so let's put that there. This could be a lot of work, okay? And I want you guys to remember this stuff because this isn't going away. This is still a skill I need you to have to be able to distribute all of this out. Now, my suggestion here, especially when you have 4 things, kind of do 2 at a time. And what I mean by that is, like, I see these nice 2 right here. I know that I have an x minus 2 and x plus 2. So I'm going to pick these 2 first. I know I'm going to leave that 2 there, but I know that when I distribute this, it's going to be that reverse of a difference of squares. So this is going to be x squared minus 4. Okay? If you don't believe me, go ahead and FOIL this out. The minus 2 and the positive 2 should cancel to this. Now this is what I mean by do a couple at a time. You did these 2, so why don't you at the same exact time multiply or distribute, I should say, our other 2. So now this is a little goofy because it's so far away, but x times x is x squared, and when I do outsides I get 2x, insides 1x, so plus 3x, and then my last 1 and 2 multiply to 2. Okay? Now I've taken care of two factors in each piece at one time, so it's a little bit less work. I've kind of combined my work. Now let's see here. This is going to be a little, I don't want to say tricky, but just you have to be really careful when you do this. So x squared times x squared is x to the fourth. X squared times 3x is positive 3x cubed. X squared times positive 2 is plus 2x squared. Now what I'm going to do, just so you understand, I'm switching colors here. I am now going and I'm going to distribute the rest. So minus 4 times x squared is negative 4x squared. Negative 4 times 3x is negative 12x. Negative 4 times positive 2 is negative 8. Okay? So again, what I did, I kind of distributed that way, and then I distributed that way. And now I can start to clean this up. Alright, first things first, combine any like terms. X to the fourth plus 3x cubed. Ooh, these combine to negative 2x squared minus 12x minus 8. And lastly, we take care of this too. So 2x to the fourth plus 6x cubed minus 4x squared minus 24x minus 16. And that is your answer. Okay? Now, I do want to graph this. Doesn't have to be super crazy. So I'm going to sketch. I'm going to use all of my tools to make sure I can do this really quick. I already know my zeros are at negative 1. Actually, let's change colors here. Negative 1, 2, and then negative 2 with multiplicity of 2. Okay? What else do I know? I know my y-intercept. That's really nice. My y-intercept is negative 16. Remember, don't count that out. Just put it on there, okay? The last thing, my leading coefficient, my end behavior comes from my leading coefficient and highest degree term. So I'm looking at this 2x to the fourth. So if y is equal to 2x to the fourth, that means I am going to be what? X to the fourth means it's going to look like a parabola. Positive means it's going up, up. Okay? So, up, up. And now let's take a look here. Okay, at negative 2, I have to bounce, right? It has multiplicity of 2. So I'm going to have to do one of these and bounce right back. And then I have to kind of turn so I can go through and grab this x-intercept and this y-intercept, and then finally my last x-intercept, something like that. Okay? Alright. I want to do the last problem. I know the video is getting a little long, but it'll be shorter than last time, so that's a small win. Small win. Okay, let's take a look at this last problem. First things first, we want to get the end behavior. End behavior always comes from the term with the highest degree. So I'm looking right here. I know it's going to be y equals 4x cubed. And what does that mean because it's positive? It's going to start down, it's going to end up. Sweet. Find the zeros. We cannot find the zeros in their multiplicity unless we factor. Okay, so I'm going to rewrite this. 4x cubed plus 10x squared minus 4x minus 10. Okay, we got to factor. Okay, we have 4 terms. First things first, though, I see these are evens. Even. Okay, I'm going to factor out a 2 first. Okay, so 2, which should leave me with 2x cubed plus 5x squared minus 2x minus 5. That looks good. Now I have 4 terms. When we have 4 terms, the easiest way to factor is to try to group them. Okay, so we are going to do that. We're going to group this. I'm going to take these 2 pieces, I'm going to take these 2 pieces, and I'm going to see what I can factor out from each of them individually. Now, this 2 out in front, I don't want you to get super confused, but remember that we're doing stuff, we're going to factor inside these parentheses. And I use parentheses when I factor. So what I'm going to actually do is I'm going to make some brackets so that I don't get confused. I still have parentheses here, but I'm going to have more parentheses inside, and I don't want you guys to get confused with what I'm working on, okay? So when I look at 2x cubed and 5x squared, I can only really take out an x squared, which would leave me with 2x plus 5. And if I look here, I can really only take out a negative. So I'm going to take out a negative 1, which again leaves me with 2x plus 5. Now hopefully this makes sense why I changed these brackets, because I did not, again, want you to get confused and like worried about all of the different parentheses that we're going to use. But now, what's the idea? Well, when we factor out this 2x plus 5, we're left with x squared minus 1. So I'm going to have 2 times 2x plus 5 times x squared minus 1. That is right now my f of x. And the last thing, we're not quite done yet. I'm going to come over here to finish this up. What can we say? We can say 2x plus 5, and then what is x squared minus 1? It's a difference of squares. Okay? Sweet. All right, so we now can get our zeros. I have a 0 at 1. Sorry, let me make this list better. Zeros. I have a 0 at 1 with multiplicity of 1. I have a 0 at negative 1 with multiplicity of 1. I also have a 0 at, what are we going to, negative 5 halves, which also has a multiplicity of 1. So all of these are going to do what? They're all going to cross nicely. They're all going to cross nicely. Sorry, I just saw I was off the page a little bit. Hopefully you guys were good with that. Okay. So we can plot all those. 1, negative 1, maybe negative 2. So maybe like right here, and right here. Okay? This is negative 5 halves, negative 1, 1. Y-intercept, look at the original. The original, my y-intercept is negative 10. And I already had my end behavior, right? I already said it was going to be down to up. So now, oops, sorry, I didn't write this. 0, negative 10. Now we draw the graph. So we have to cross everywhere. So I'm going to cross, I'm going to cross, I'm going to come down, I'm going to grab my y-intercept, I'm going to cross, and then just kind of, I know that not perfect, but that'll do. Okay? So, very last thing. Domain and range. Just look at the picture. We've done this before. We know that our domain, and we should remember because these are continuous, negative infinity to infinity. Or, what can you say? All real numbers. How about range? Range, it looks like it's going down forever and it's going up forever. Even though over here it stops at negative 10, it's still going down forever. So once again, negative infinity to infinity. Okay, so this was multiplicity. Hopefully you guys are starting to pick up on it and seeing the difference now between multiplicity, or when there is multiplicity and when there is not. All right, have a good day.